Hi, I'm Patricia Morris,
I'm Vincence.
and we did our drug presentation on Deutetrabenazine. Deutetrabenazine is sold under the name brand Austedo. It's used to treat movement disorders like tardive dyskinesia and chorea from Huntington's disease. Tardive dyskinesia is a side effect of antipsychotic drugs and other medications, and it's a result of blocking dopamine receptors. Huntington's disease is a progressive breakdown of nerve cells in the brain, and chorea is a symptom of Huntington's disease, which develops from hyperactive dopaminergic neurotransmission. Tardive dyskinesia and chorea are both involuntary movements of the body, and tardive dyskinesia especially has involuntary movement focused on the face. And here is actually an image from a person experiencing one of these movement disorders. Some of the properties of this drug are that Austedo is a racemic mixture of RR-deutetrabenazine and SS-deutetrabenazine. Prior to this drug being approved, the FDA had only approved homochiral drugs for 8 years until they approved this one. And the drug tetrabenazine had previously been used for this same purpose, but deutetrabenazine was developed to decrease side effects. And that is because of the deuterium in the compound. This deuterium increases the half-life of the active metabolite, which is because the higher mass of the deuterium creates a stronger CD bond, increasing its lifetime. And this increased half-life allows for less frequent doses and for lower daily dose amounts required for the same exact results.
So this drug acts as a selective vesicular monoamine transporter 2 inhibitor, which is also known as VMAT2. And then what VMAT2 does is uptakes amines into the synaptic vessels. And so what this drug will do is decrease the reuptake of these monoamines to the synaptic terminal, which is pretty much like these neurotransmitters that are listed. So deutetrabenazine alleviates symptoms related to chorea from Huntington's, but does not slow the progression of any of these diseases. And in clinical trials, there's evidence of deutetrabenazine working to also combat the symptoms of tardive dyskinesia by reducing abnormal involuntary movement scores. For retrosynthesis, we formulated a three-step plan to get our drug. In our first step, we'll be aerating the left side of our starting reagent right here, and it'll be under reflux in ethanol. For our second reaction, we'll be cleaving these two ethers into alcohol groups using HBr. And then in our last step, we'll be using the Mitsunobu reaction to then displace these hydrogens and then turn these functional groups into ethers.
So the first step in our mechanism is an SN2 reaction, where this nucleophilic nitrogen is going to attack this carbon, kicking out this positively charged nitrogen. In the next step, we have a ketoenol tautomerization, which naturally progresses. Normally it would want to sit over here, but for our purposes, we actually want it to be the less favorable enol. So we're going to assume that this reaction proceeds that way. And then in this step, the enol is going to have the electrons from the oxygen pushed down, and then we're going to actually form a ring here while pushing these electrons over to the nitrogen. In our next step, this methanol is going to deprotonate our oxygen and take off that positive charge. In the second part of our mechanism, our hydrobromic acid is going to protonate our ether, and then our anionic bromine is going to come back and attack this carbon, and here the oxygen is going to take back its electrons, effectively cleaving our ether. And the same exact thing is going to occur at our other ether over here, where it gets protonated by this acid, and then this bromine is going to come back and attack the carbon and cleave this ether here. We end up with this product.
For the first part of our third step, phenylphosphine will be performing a nucleophilic attack on one of the nitrogens on diad, which then pushes the electrons from this double bond onto another nitrogen. From there, the nitrogen anion will then suck off this proton on one of the alcohol groups on this product. And then from there, our methanol D3 will then perform a SN2 reaction on triphenylphosphine, which removes it from this group. And then the nitrogen anion here will then pluck off the proton and then send the electrons to the oxygen. The next step, this oxygen will undergo resonance, where the electrons will then go here to form a double bond, and then the oxygen will be taking the plus charge. From there, this oxygen anion that we create at the beginning will then perform an SN2 attack on this carbon here, which then releases this oxygen. And then the same reaction will happen on the other alcohol group. So from the beginning, this nitrogen will pluck off a proton, send here, and then our oxygen on our methanol D3 will attack the triphenylphosphine, which then plucks off this proton, undergoes resonance, and then this will form here, creating our final product, the deutetrabenazine. And here are our references. Thanks for listening.